N2.L2.4. A 2 kg block is pushed upwards from underneath by a constant 50 Newton vertical force. The block is sliding on the bottom side of an inclined plane that makes an angle of 70 degrees with respect to the vertical. The coefficient of kinetic friction between the block and the plane is 0.2. So part A is asking us to determine if the net force points up or down this incline. So basically, what is the direction of motion of this block? So the first thing we're going to want to do is draw a free body diagram of all the forces. And since this is on an incline, I'm going to make my x-axis parallel to the slope that the block is moving on, like this. And one force we have is the push force upwards, and I'll call that Fp. Then we have the force of gravity downwards, Fg. And then we have a normal force going directly perpendicular to the slope. Call that Fn. And then we have the force of kinetic friction, but we don't know which direction that's going in because it's dependent on the direction of the net force, which is what we're trying to determine. So whichever way the net force points, the force of kinetic friction is going to point the opposite way. So it could be up the slope or down the slope, we don't know. And we're going to call that FFK with a question mark because we don't know the direction. So now how do we determine which way the net force points from these forces? Well, the net force is going to point up or down the slope, we don't know which way, and the two forces that have x components, up or down the slope, other than the force of kinetic friction, are the push force and the force of gravity downwards. The normal force is perpendicular to the slope, so it's not going to contribute to the net force up or down the incline. So let's look at the force of gravity first. We're going to have same graph, force of gravity downwards, and the force of gravity is going to have two components, an x and a y component. And we're going to call this Fg sub x. So what we want is the Fg sub x. So how do we get that? Well, the force of gravity is going to equal mass times acceleration due to gravity, and they told us the mass was 2 kilograms, so we're going to do 2 times 9.8, and that comes out to 19.6 newtons. And that's just the magnitude downwards of the force of gravity. So how do we determine Fgx? Well, they told us that this angle is 70 degrees, so that means that this angle must also be 70 degrees. So this angle, this angle, this angle, all of these angles are 70 degrees. So what we would have to do is do 19.6, the magnitude, times the cosine of 70, and that equals 6.703 newtons. But this is down the slope, so in our coordinate plane that's negative. Now let's look at the force of the push upwards. So the push force was directly upwards, and we found that this is 70 degrees, and it's also going to have two components. It's going to have an x component and a y component. And this is Fpx. This is what we want to find. So they told us that the push force had a magnitude of 50 newtons. So we just have to do 50 times cosine of 70, and that gives us 17.101 newtons. And that's in the positive direction because that force is going up the slope. So now that we've determined the push force in the x direction and the force of gravity in the x direction, all we have to do is sum them together to get the x net force minus the force of kinetic friction. And we can write what the net force in the x direction equals as F net equals force of push in the x direction plus force of gravity in the x direction plus the force of kinetic friction, which we don't know right now. And that would come out to F net equals 10.3974 newtons plus some unknown force of kinetic friction. But we already know from this information that the block is going to be moving up the slope. And that is because the force of kinetic friction is going to be opposite the sum of the other two forces in the x direction, net x, and it's not going to be big enough so that it overcomes those other two forces. It's just going to resist motion in that direction. So that's the answer to part A, is up the slope. Now part B is asking us if after traveling a total distance of 4 meters, the block is traveling at a speed of 4.43 meters per second, which is the final velocity, up the incline, what was the initial velocity of the block? So here we have a change in x. I'm going to put part B, change in x equals 4 meters, and the final velocity is 4.433 meters per second. And we know that that's positive because the block is going up the slope. So now we have to find what was the initial speed. So we can use this formula to figure that out. Velocity final squared equals velocity initial squared plus 2 times acceleration change in x. So we know the change in x, we know the final velocity, but how do we find the acceleration? Well, we can determine acceleration from net force because the net force in the x direction is going to equal the mass of the block times its acceleration in the x direction, which is what we care about. So we previously determined that the net force in the x direction equals 10.3974 newtons plus the force of kinetic friction. But we don't know the force of kinetic friction, so we have to figure that out. So the force of kinetic friction equals the normal force times the coefficient of kinetic friction that they give us. But how do we determine the normal force? So if we redraw our diagram here, the normal force is going to be the sum of the forces in the y direction. So we have a force of gravity going that way, a push force going that way. Now we want to look at the push force's y component, Fp in the y direction, and the force of gravity's y component, Fg in the y direction. Because the normal force is going to be the sum of these two forces. One of them is negative and one of them is positive. So the normal force is going to equal F push in the y direction plus Fg in the y direction, which equals, instead of cosine now, we just do sine, 19.6 times sine of 70. But remember, that's downwards, so that's going to be negative, plus 50 times sine of 70, and that comes out to 28.5667 newtons. And now that we have the normal force, we know that normal force times the coefficient of kinetic friction, which they told us was 0.2, is going to equal the force of kinetic friction. So we have to do 28.567 times 0.2, and that comes out to be 5.71333 bar newtons. That's our force of kinetic friction. So now that we have the force of kinetic friction, we can plug that into here, and we can do 10.3974 minus 5.71333 because the force of kinetic friction is opposite the net force, and that's going to come out to 4.684 newtons. So that's our net force in the x direction. And that is going to equal mass times acceleration in the x direction. So now we know that acceleration in the x direction is just going to be 4.684 newtons divided by 2 kilograms because that was the mass of the block. So we can plug that into our kinematics formula, and we can get that the final velocity, which they told us 4.433 squared, equals the initial velocity squared, which is what we're trying to find for part B, plus 2 times the acceleration, which is going to be 24.684 divided by the mass, 2 kilograms, times the change in x, which was 4 meters. And you shift those things around and you get that the initial velocity is 0.95667 meters per second, or about 1 meter per second. And that's the answer to part B. Thanks for watching.